Welcome back. In this tutorial we are finally going to talk about the fluid flow CFX. Let's drag and drop the fluid flow CFX from the analysis systems. We can also generate one through the component systems. It's the same one with generating a fluent system. The only difference is instead of fluent we would use CFX. So let's generate through analysis systems. We already had a geometry this time. We are going to import geometry and select it, and let's model it in design modeler and make it ready for flow studies. Let's select generate here. So when we first generate our geometry in the design modeler for a CFX study, the first thing that we need to do is make sure that one of these coordinate systems goes through the center of our geometry. It's very important. So let's check for our geometry, and as you can see, the y coordinate system, the y-axis, goes through the center. The reason why we are going to be doing this, I will explain it in a bit, but make sure to check this. And if one of these axes are not going through the center of your geometry, you can move your geometry through these body transformations. We talked about this in the geometry tutorial. The reason why we do this is, first of all, let's talk about CFX. Why we need CFX? CFX is a software that allows you to model turbo machinery, the rotating machinery, and the flow studies around rotating machineries better. You can also do these studies through Fluent, but if you do them through Fluent, you need to set up your mesh differently. And instead of doing that, instead of changing the mesh type, we can generate it in CFX, and instead of messing with the mesh, we will be generating rotating domains and stationary domains. It might seem a bit complicated at first, but it's very simple. What we are going to do is we are going to generate two domains around this fan, and we are going to define a rotating domain and a stationary domain, and we are going to make that rotating domain rotate around one of these axes. In our case, we are going to make it rotate around y-axis. So let's start by naming this solid object and making sure that it's named as solid, and then we can name this as fan. And we are going to generate two enclosures around it. First one is going to be a cylindrical enclosure, and we are going to generate it around this one. This enclosure is going to be our rotating domain, so we will try to make it as smaller as possible around this one, because the rotating domain will only happen for this fan, and we need to make sure that this rotating fan is covered with that rotating domain. So we are going to select cylindrical, and we are going to select the y-axis alignment, so it is going to align as our fan, and we will try to reduce this number. So we will name this as the rotating domain, and then we are going to generate another enclosure, and this is going to be our stationary domain. It's going to be a box, and let's generate, yes, around this part. So we can reduce some of the numbers here to make it smaller so that our mesh is generated faster. So yes. So now what we are going to do is we are going to first of all name this as the stationary domain. And then we are going to do two things here. We are going to first of all remove this fan from the rotating domain, just like we did with the geometry tutorial. And then we are going to remove this rotating domain from the stationary domain. But while removing the domains from each other, we are going to do something differently. So let's first of all generate our first Boolean operation and remove this fan from this rotating domain. And we are not going to preserve the tool bodies here, and let's generate. And right now we are going to generate another Boolean operation, and we are going to remove this rotating domain from this stationary domain, but this time we are going to preserve the tool bodies. This is very important. We are going to preserve the tool bodies here, and when we generate, as you can see, we can still see the rotating domain inside. And the reason why it's important is we are subtracting this rotating domain from the stationary domain to make Ansys understand that these two are separate domains. but we are not completely removing this rotating domain from the stationary domain as we did with the fan inside the rotating domain, because they need to exist separately, because this will be rotating and this will be normal. So this is it for the geometry part. Let's move on to the mesh. So first thing here is, as you can see, our solver preference is selected as CFX. We talked about this in the mesh tutorial video. So let's just generate a mesh. Let's not change any settings first, and if we have problems we can go back and fix. So this is going to be our mesh. The important thing here in CFX is the named selections, and this is the important part, so please follow this very carefully. So first let's get the simple part out. We are going to name this as the inlet, and we are going to name these here, instead of walls we are going to name them as opening. So we are not going to define an outlet for the stationary domain. So let's first look at this. We have inlet and we have opening. So this is going to be the important part here in the named selections, is we are going to name this internal domain twice. What we are going to do is, there is a interface between the stationary domain and the rotating domain, and this interface needs to be defined in CFX setup. And in order to define that, we are going to do named selections on the outer and the inner part of the rotating domain. So what we are going to do is, the outer part of the rotating domain that touches the stationary domain will be named separately from the inside part of the same part, so that in the setup part we can individually select interfaces and define them. You are going to understand what I mean in a bit, but let's try to name them separately now. So we are going to hide this face first and hide this face as well, and let's hide this face as well. So now when we first select this, as you can see, we have the top part. We are going to name this as inlet station. So this is going to be from the stationary part, and we will select OK. And then we will right click, we will select this, right click and select hide face. And when we select this again and look from the bottom, as you can see, this is the inside part. We are going to name this part as inlet rotating. And when we once again hide this face as well and select, this time we select the shroud. So we are going to name this part first as the shroud, and right click, select this, right click and hide face. And when we select it again, this time we have the inside part, and once again and finally the outlet of the rotating domain, and we do a named selection here. We select it as outlet and then hide this face here, select it again and rename it. So what we are going to do is right click and select show hidden faces, and we are going to use the box select to select this inner geometry and name it as fan. It didn't select all of it, it's okay, we just click outside and make sure that we get all of it, but we don't get the rotating domain. So now it's okay. Let's control it from the top as well, yes, and we name it as fan. So now let's control all the named selections. We have our inlet, we have our opening, simple ones, and the inlet rotating. Okay, we need to have another one right here. Good. The shroud part, the rotating part, great, and the outlet, and the inside, and the fan. Nice. So now what we are going to do is upload it into the CFX part and carry on with our simulation. And let's run the setup. So in CFX, setup and solution will come differently. So when we are launching the setup, we will just launch the setup part. So this is CFX. We see the different tools of CFX here. So what we are going to do here is, first of all, we are going to insert a domain to define our rotating domain. And we are going to select the location of our rotating domain as this one here. You can also select different ones. We are going to select this one. And we are going to say that it is a rotating domain that rotates around the global y-axis with the rotation speed of, let's say, 300 or let's say 500 RPMs. Let's select apply. So we get this error. It's okay for now. We will deal with this. Let's select OK. So this error is due to the interfaces. So what we are going to do now is we are going to define the interfaces. So let's select the domain interface first, and let's select inlet domain. What we will do here is select the default domain here and select the inlet rotating and select the rotating domain here. We are going to select the inlet station, and we are going to say that it's a frozen rotor with specified pitch angles of 360 degrees, and let's select apply and OK. And we are going to do that also for shroud and select here the default domain, select the shroud here, select the rotating domain and select the shroud here. Once again, frozen rotor, specified pitch angles of 360 degrees, and apply and say OK. And once again, interface, this time we will be doing it for the outlet. And once again, we select default domain, outlet, rotating domain, and outlet. And frozen rotor with specified pitch angles of 360 degrees. And as you can see, the error has disappeared. We have defined all the interfaces here. So the error has disappeared. We can check them again. So what we are going to do here is we are going to define for the default domain, we are going to define certain boundaries. And the boundaries we are going to define are two. One is inlet, which will be defined at the inlet here. And it is going to have, let's say it has 20 meters per second. And apply and OK. And we are going to define another boundary for the openings which surround this, and this is going to be defined at the opening. As you can see, it's automatically selected because of our name selections. We must select certain values here. Let's select the pressure as the atmospheric pressure and just apply. So we have our inlet velocity, we have our rotating domain, we have the velocities, and we have the interfaces. So these interfaces, as once again, if you didn't understand previously, what we did here was this is going to slide through the rotating domain. So the rotating domain, which is this one, inside it is going to rotate inside this domain. So the parts that these two domains meet need to be defined as interfaces into the CFX solver. So after defining all these, we can go to this solver part and select solver control and edit. So this is just like Fluent type. We are not going to change a lot of things here, but this is basically the solver iterations, the same as the Fluent part, and this is the residual target. As you also remember from the Fluent part, we are not going to make any changes on these settings, but if you do want to make changes, you do them through here. So let's close this window. Again, these are completely about if you have a good system or not. So we are not going to make changes here and just start to run. If you have a problem with your setup, if you have a problem with your model, with your mesh, whatever, you are going to get errors here, and your solution will not happen to start with. If your solution does happen and you get weird results at the end, then you can always go back and change your mesh or geometry. But most of the time, for example, the interfaces that we defined there, if you make a mistake in there, you are going to get an error here. or if you make a mistake with your boundaries, you are going to get an error here probably. So if your solution has started like this, then this means that you first of all defined your interfaces correctly and the Ansys is able to understand and read them. So after the solution ends, we get this message that says the end of the solution stage, and we can close this window and go to results to investigate our results. So we are going to generate a plane here again, the XY plane. Let's generate one and select a contour. Let's look at velocity on plane 1. Yeah. So this is the velocity contour, as you can see. And the important thing here is of course the streamlines. So let's look at streamlines. Let's define some from the inlet and apply. So yes, as you can see, we can see the rotation here. Let's reduce it to 50. And we can select this one as well to show it in both parts. And let's animate this. Let's reduce it to 25 first and animate this. And when we select animation, streamline. It's too fast right now. So yes, as you can see. So this is how we do simulations on CFX. You can also increase the rotating domain around the fan, the size of it, to model a larger rotating domain, but it's okay to keep it as small as you see here. So this was the CFX tutorial video, and thank you for watching.